Yesterday, we looked at multiplying and dividing integers using models and number lines. Today, we're going to look at how you can know if your product or your quotient is going to be positive or negative when you don't have those models and you don't have those number lines. When you're working with larger numbers, the last thing that you want to have to do is draw out a model representation. If you're dividing 75 by 5, you don't want to draw out 75 circles. Okay, so let's look at the rules. And a lot of you had made this realization as we were working through our problems yesterday. If you can remember this, then it will make it to where things will become much more simple for you as you are practicing, as you are multiplying and dividing. Things will be much simpler. So let's look at these rules. What happens is, if you are multiplying and dividing and the signs are the same, your answer will be positive. So as you can see in these examples here, we've got a negative number, a negative 6 times a negative 3 gives us a positive 18. And then we have a positive 35 divided by a positive 7 gives us a positive 5. So if the signs are the same, then your answer will always be positive. If the signs are different, however, then your answer will be negative. So if they're different, they will be negative. Look at these examples. We have a negative 5 times a positive 4. So our signs are different. We end up with a negative 20. A negative 42 divided by a positive 7 gives us a negative 6. Signs are the same, it's positive. Signs are different, it's negative. One visual way you can use to help you remember is to draw a tic-tac-toe board and then to create a tic-tac-toe diagonally with positives and fill everything else in with negatives. And then if you use this section of your tic-tac-toe board as though this was the equal sign, you can use this tic-tac-toe board to easily help you remember. You can look back and say, okay, well, I'm multiplying a positive times a negative, so my answer is going to be negative. Or I'm multiplying a negative times a positive, so my answer is negative. Or I'm multiplying a negative times a negative, and I get a positive. And lastly, a positive times a positive is a positive. So this is a way to help you keep that in mind. We're going to do some practice problems. I'm going to use the tic-tac-toe to help me on every problem that I do. So I'm going to quickly make my diagonal positives. And then let's look at this problem. We have negative 4 times negative 11. So this is a negative times a negative, so my answer should be positive. And then I know that 4 times 11 is 44. It's as simple as that. Using the multiplication and division that you already know, coupled with this tic-tac-toe, and you are good to go. There is no reason why, if you struggle with remembering the rules of like signs is going to be positive, different signs is going to be negative, there's no reason why you can't draw that tic-tac-toe board on the top of anything that you're doing and refer back to it. You don't have to draw it for every problem. Draw it once on your paper. So here we have a negative divided by a negative. Well, on our tic-tac-toe board, a negative divided by a negative will be a positive. And then 54 divided by 6, well, we all know that is 9. Easy peasy. Tic-tac-toe to help us remember, to show you that it can be used on all these problems. We have a positive that's being divided by a negative. A positive being divided by a negative would be right here. A positive divided by a negative is going to give us a negative. So I'm going to put my negative sign there. I always try to take care of that first and then do the math. 48 divided by 6 is 8. So 48 divided by negative 6 would result in a negative 8. Look at another one. Make that positive diagonal tic-tac-toe. Now I have a negative divided by a positive, negative divided by a positive. So my answer is right here, because this is our equal sign, is going to be negative. And then 32 divided by 4, well, everybody should have that one already memorized as 8. Of course, this also applies in word problems. The price of jeans was reduced $6. So reduced should tell you that we're going to have a negative 6 per week for 7 weeks. By how much did the price of the jeans change over the 7 weeks? So each week it was reduced to $6, and that happened for 7 weeks. Time, of course, cannot be negative. So I'm going to then multiply these together. $6 decrease every week for 7 weeks. So I've got let me draw my tic-tac-toe board here. I've got a negative times a positive. So that's right here. It's going to equal a negative. And 6 times 7 is 42. So the price changed a negative $42. Flor made 7 withdrawals. So we also know that withdrawals, taking money out of the bank account, results in a negative, so negative 7, of $75 each week from her bank account. What was the overall change in her account? So negative 7 withdrawals of $75 from her bank account each week. What was the overall change in her account? Let's see. I think I'm going to change the way that I set up this problem, because the action of the withdrawals should be a positive 7. But if you're taking withdrawals of $75, the 75 is what's negative, because we're taking that out of the account. So I, at first, when I read this problem, was applying the word withdrawal to the wrong number in the problem. We would have ended up with the same results, but I want to go ahead and make sure that I have set it up the right way, because in another case, it might matter. So I've got a positive times a negative, so I know I'm going to get a negative, and I'm going to go ahead and come over here and actually work out the math. 7 times 7 is 49, 525. So this resulted in a negative $525 in her account. Let's see what this one says. Clark made 4 of his truck payments late and was fined 4 late fees. Uh-oh. The total change to his savings from late fees was $40, negative $40. How much was 1 late fee? Okay, so 4 late fees, the total change was negative 40. So this is going to be negative 40 divided by 4, because the total change is how much all of those late fees cost him. So I've got a negative being divided by a positive, so my answer is going to be positive. My answer is going to be negative. Negative divided by a positive is a negative. The signs are different, so it's going to be negative. And 40 divided by 4 is 10, so it's a negative $10. Go ahead and draw my tic-tac-toe board. Alan's score in a video game was changed by negative 75 points because he missed some targets. He got negative 15 points for each missed target. How many targets did he miss? Okay, so it changed totally by negative 75 points, and it was negative 15 points for each missed target. So I'm taking that negative 75 and I'm dividing it by 15. This is a negative divided by a negative, so I'm going to get a positive. And then 75 divided by 15, let's see, I can count that by 15. So I got 15, 30, 45, 60, 75. So 1, 2, 3, 4, 5. He missed 5 targets. Sometimes you're going to be multiplying more than 2 factors or more than 2 numbers together, but it's very easy to know if it's going to be positive or negative. all you have to do is count up the total number of factors, the total number of negatives. Let's change this to negatives. If that total number is even, your answer will be positive. If the total number of negatives is odd, then your answer will be positive. Okay, so right here we've got 1, 2, 3, 4 negatives. So our answer would be a positive 1. Because remember, if you are multiplying same signs, then it's positive. Excuse me. If the total, excuse me again, sorry guys. If the total number of negatives is odd, your answer will be odd. So here, these two are the same, so that's going to make this a positive. And then you have a positive times a negative, which means you're going to have a negative 1. So let's look here. We've got 1, 2, 3 negatives. So that's odd. So that means that our answer is going to be negative. 2 times 3 is 6. 6 times 4 is 24. So we would get negative 24. But in this problem, we have 1, 2, 3, 4 negatives. So since it's even, our answer will be positive. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16.